Gonzalez. He's from one of the most amazing towns in Spain, Cordoba. He's a veterinarian and he's finishing his PhD in behavioral genetics, probably the leading and the only expert in donkey genetics. And with that, I'm going to turn it over to Javier.
Thank you. Well, as Amy has said, I'm Francisco Javier Navas from the University of Cordoba. And what we are going to do today is to speak a little bit about what's the background of genetics in donkeys concerning cognition and intelligence. First of all, we're going to do a review of history and why the donkey got the emerited cognitive position that it has today. So we need to go back to the current first domestication evidences, which bring us back to 4,600 before Common Era, in which we find the first finding of a donkey skeleton in Egypt. And still, there wasn't any evidence of domestication in this species. However, we have to go back to Abydos and Haror, in which we find the first evidences for domestication and from the work with this kind of animals. In the first slide, we can see that vertebra was modified because of these donkeys were used to carrying loads. And in the second one, we see a bit, which is used in donkeys. If you pay attention to the information that is given, it's likely that these donkeys weren't actually used to be ridden, but they were something important because they were like buried next to the owner. So, I see we are moving forward 1,000 years. If you go to any museum in the world, the first thing that you become aware is that we haven't invented anything. And it happens with donkeys. Now we're speaking about facts as donkey milk production, work in the field, donkey assisted therapy, and we find slides from tombs in Egypt which shows that donkey husbandry was really important. I mean, as important as any other cattle. This slide is very important. It depicts a cattle camp. This was an economical important event, and the figures that we have here makes you think of the relevance of these species. If you count the numbers of donkeys, which are 760, they almost resemble the number of cows that were held in this event. But how did we got the donkeys to be here? Well, if you think of the use that donkeys were being provided historically, we think of working on the field, meal production, it's okay. But what we do not know is that donkeys were also being used as war animals. This is the standard of fur. This is an item from which we do not know the real use that it had. And what we can see here in this picture is the piece panel. It shows work in the field with donkeys. But what happens if we turn this item the other way? We find carriages that were drawn by onagers, which actually are with donkeys. How did they get these donkeys? This is important. If you go to the British Museum, we were likely to see some reliefs by Ashurbanipal. Ashurbanipal was the last important Assyrian king. And if we have a look at these onager hunts, it depicts the way in which these animals were hunted to make use of their meat. But what happened with some of them were captured, and they were used to work in the field and to breed for more animals. We see in the same palace, we can see even depictions of the donkeys already carrying people. So that gives you an image, and it helps you picture how important they were. What happened is that after this importance, then myth and superstition played its part. And we don't have to go like farther from Egypt. We can remain in Egypt, and this species thought it to be linked to bad characters, to demonic characters. In this case, I'd like you to pay attention to this kind. For the most of you, you may be able to recognize centers, but who of you knows about onocenters? Please pay attention to the last part, where it says, the creature has a violent temper. At any rate, if captured, it will not endure servitude. And its yearning for freedom declines soul food and dies of starvation. This also is the account given by Pythagoras. So, how many of you have heard something about this, about donkeys? Yeah, we are starting to get that from the religion and from superstitions. We were getting the information that was starting to change the conception that we had of donkeys. Then it continues, even the late time for Egyptians, for all Egyptians. We have this papyrus which depicts a spell of separation of two people. And the first thing that comes to our sight is the picture of Seth, which was the god of death. If you see these letters, is Seth in Cretan Coptic language. And also the connection with between Seth and the Greek god Typhoon make like this situation get worse and worse and worse. Even by the late stage in this period, citizens in some towns were likely to charge all the wrong things that had happened to the towns onto a donkey and then throw it over a cliff, so that they were getting rid of all the bad stuff that could happen to a town. So it's likely to understand that this conception brings us to the place that we are today, because we haven't changed that much. How do we know that? I mean, you know the bad connotation that language can have when it regards donkeys. We know that ass is someone that is not very clever. Hopefully in English, I know we use the term smart ass, which is something good, so things are changing. Here we have some examples. You can turn the donkey into a thoroughbred. Some of the fables by Aesopus, in this case, the golden ass. A person was turned itself into an ass because he was trying to become something else. In the middle, he got caught and became an ass. So now, what I want you to be aware of is that this situation affects breeds until our days. This is the breed that I work with, the Andalusian donkey. This is a creature that brought me here, and which I'm really, really pleased to show you, and I'm flattered to work with. The situation that I'm going to speak about donkey breeds in Europe, it's almost common to all breeds in the world. I'm often told, when I say that, the important thing about donkeys is that it's endangered as a species. I'm often told that if you have many donkeys, this is not an endangered species. But what happened in donkeys is that we do not know anything about the structure. We do not know which are the breeds, how they organize. And the worst thing, apart from being endangered, is not to know whether they are or not, because we do not implement measures to correct it. So, in this case, 75% of the population is gathered in less than 50 kilometers. What happened if there's a catastrophe? We lost it. It's true that it's following an expansive trend, because we are starting a worldwide distribution. There's some Andalusians here in the United States, in New Mexico. But the truth is that, I don't know if you are owners of donkeys, and you know that it's really hard to get to know the relatives of the donkeys. We barely know fathers. I mean, in this breed, we only know 47% of the parents. So we do not know. I mean, even if we assess for inbreeding, we are reporting a bad figure, because actually when we tested in this paper that you can see there, when we were reporting 1% of inbreeding, when we process all the data only on the population that we know the parents, it increases until 28%. When inbreeding goes upper than 1%, we start seeing like very detrimental signs in the animal. It means, well, inbreeding is something really interesting, but what we first see from inbreeding is that we do not see anything. I mean, the first thing that we have from inbreeding is that reproduction traits fall. It's not a problem. I mean, donkeys are reproductively efficient, but because of the inbreeding, which is something that we cannot control because we do not know which is the background, we do not know that we are receiving these results of reproduction because of the animals being really related. Also, the problems that they have from the immunitary system. There's some illnesses. We've been seeing the talks before this one. And these illnesses may be related to a high level of inbreeding. Okay, donkeys are particular at any field that you try to study, and genetics is not a different thing. The first thing that we know is that hair follicle keratinized. So, although we can use the hair to take samples, for example, for parentage testing or whatever, they are likely to be lost. So the best thing to use is blood. This doesn't happen in other species. If we compare to horses, it may be likely that if you get hair samples, you may be able to get like a great amount of DNA, so everything is perfect. But with donkeys, some of them are ruined. So, and the other thing is that from the quantitative genetics point of view, we found out that pedigree level are so incomplete that how come are we going to speak about genetics if we do not know where the animals belong or where they come from? Furthermore, if you have been working with donkeys, you may be able to know that it's really hard to get a large sample, a large number of animals for you to study. This happens, I mean, for some science, it's enough to have 32 donkeys, 60 donkeys, but for genetics, we are working with 300 animals and we are already on the low level. I mean, this is the minimum level to get like significant results. How do we solve this? In the case of the adolution, what we do is we have all the relationship between the pedigree tested. We know that each animal belongs, I mean, we know that the parents that we have are the parents of this animal for real. Okay, so when we try to approach characters in donkeys, we need to know that we face two different types of characters. The first are quantitative traits. These quantitative traits occur as a continuous range of variation. We can count them. You see scales. Imagine the body measures of a donkey. They're decimal. If you have decimal numbers, you can count them. And the truth is that we know that because of this variation, these traits may be attributed to a great number of genes which have relationship among them. The other kind of traits are qualitative traits. For example, these are the ones that fall into natural categories. Don't get mistaken about what natural categories means. I mean, we can say, okay, we can show the height of a donkey and say we have tall donkeys, standard donkeys, small donkeys. This is not the way. I mean, sure, it's not a natural category. Because where do you set the limit? When an animal is short, when it is tall, we do not know. And the truth is that these kind of characters may be attributed to single gene or a small group of genes. So this is really important because it simplifies the work. Quantitative traits. From my own research, what we have done regarding quantitative traits, it's the estimation of problem-focused copying style. Copying style is the reaction that animals have towards novel stimuli. And also the work with 16 cognitive processes, which is something that I'm going to speak later. As I said, many of the things is just when you can have a numeric scale, we can use it as a quantitative trait. What happened with qualitative traits? We word them with categories. It could be the example of blood groups, disease, resistance, gaits. For example, one of the things that we got while studying this paper about gaits is that when you had an ambling male, all the offspring was able to amble. But when the female ambled, it didn't make them amble or not. I mean, it doesn't make it the offspring be an ambling one. So this tells us that this character may be sex-related, not sex-linked, because it's not transmitted through the Y chromosome. Something really interesting. Okay, now I don't want you to guess, Carl. We're going to turn to the mathematics, and I'm going to just look at the idea, not the mathematics. Okay, we know that phenotype, what we can measure, what we can see for real, is a combination of the genetics of the animals and of the genotype of the animals. And it's also affected by a certain error. Why this error happens is that we are not able to control all the factors that are involved in any trait that we want to measure. Some of them have never been studied, and some of them we do not know that are playing a role. So, when we turn this, we need to learn a little bit of concepts. We work with matrices. Matrices are tables. We order the data concerning the observations that we have from the field and the factors that may be involved, the animals, and all around, and we try to build models that can allow us to, like some kind of predict what's going to happen. If you look to the X, this concept relates to the genetic additive component, which means the value, the genetic value of each animal, but also of a permanent environmental effect. For you, if I said permanent environmental effect, what do you think that I'm speaking about? Permanent environmental effects are those from which we cannot separate the effect from the actual value of the animals. For example, imagine we have a Jenny which has a low fertility, and she has folliculitis. We cannot know whether this Jenny is predisposed to be low fertile or it's because there's a folliculitis. Furthermore, what happens with trainers? If we assess a trained donkey, we cannot know whether this animal is naturally prone to be well behaved or is because he has a good trainer. So this is a permanent environmental effect, and we have a way to control it. And then we have temporary environmental effects, which are those from which we know all categories. Oh, this is what I've been speaking about. Okay. So I'm not getting too deep in this, but I mean, the only thing that you need to know is that the first part of the equation, what we do is to connect the observation from the field with the animals. Here, there's a table in which we say, here's the observation for this particular animal. This is what we have got from the field. In the second part, we have the unknown. The unknown, I mean, it's what's the actual genetic value for each animal, and what's the actual effect of each level of each factor. For example, when I speak about levels of each factor, imagine husbandry systems. We speak about extensive, it would be one level, intensive would be another. So we are able to measure how do they affect, for example, behavior or gaits or whatever. And then the other part, the only thing that it does is connect you the animals with all the fixed effect. Imagine that we had one single model with just one single fixed effect, farm. So this matrix, what it tells you, is exactly which animal belongs to each farm. And we need to add the parentage matrix. We need to know the information about, who are the parents of who, so that we can have the genetic basis. And we add lambda coefficient. Lambda coefficient, for you to be aware, is before using lambda, the observation that we got were like disturbed by the environment and everything. And when we applied lambda, which is the heritability of traits divided by 1 minus the heritability, we got that the information that we were obtaining was unbiased. So it corrected the model somehow. Okay, so how do we decide what we include in a model? As it says here, we understand the true model the model that is able to gather all the effects that may be affecting a single character. That's impossible to gather because some of the factors we don't even know that are playing a role. The optimal model is the closest one that we are able to control and that resembles that true model. And what we work with is the operating model. That is, we get a number of factors that is like balanced with the sample that we have, and that it's easily computable. I mean, if we need to test for 300 donkeys, we cannot like check for all the factors because it would be nonsense. I mean, it would be drive people crazy. So, I'm gonna ask you something. Should we include color as an effect when modeling or measuring for example, the time that a donkey takes to perform a certain task? I'm going to say that this shows significant. I mean, there's a significant difference between donkeys that have one certain coat color and some donkeys that haven't. Imagine that we have this sample gathered depending on the husbandry system that these animals are under. So, my question are, can we compare donkeys raised and handled under different husbandry systems? What do you think? Yes, we have donkeys gathered that are handled under different husbandry systems, so we can compare them. But can we compare white or sorrel colored donkeys under all husbandry situations? No. For example, in this case, we cannot compare. So that, although this trait may be significant from a statistical point of view, it may be better not to include it and to consider this effect in the error part, because we may not represent what we have in the population. This is important, because we cannot we cannot say that RFA is playing a role when there's some places in which it's not playing this part, because the data we may obtain would be distorted. So, now I'm starting about speaking about cognition and intelligence, like in a more formal way. So the strength of the donkey mind lies in adopting a course inversely as the arguments urge, which, well considered, requires a great mental force of direct sequence. This was written by George Eliot. I don't know if you know who she is, because actually she was a woman. She was Marianne Evan. He was a writer, a novelist from the UK. And she used that pseudonymous because she doesn't want her work to be considered irrelevant. So what she actually was is that by the time it's true that they were women that were publishing their work, but they were being used, yes, for romantic reading. So she didn't want that, so that she used that pseudonym so that she could speak about psychology. This is really important because when I got to face this sentence, I mean, this lady understood me. Yeah. Okay. So, the first thing that we need to know about behavioral genetics is that it's true that genetics conditioned what we found in the individuals, but environment conditioned genetics as well. So, if we don't control the environment, as in genetics we speak about potential value. For example, you're having the best genetically background for a cow. This is the best cow ever, but you take it to a place in which it cannot develop its full ability, you may get less milk, for example, that when you use it in the environment that suits that necessities. This is really important because, for example, in cloning, even when you clone and you expect to have a same performance, you may not get it because of the environment. And maybe the genetics is exactly the same. So we need to control everything with genetics. Okay, in my studies, what we did to approach the genetic of cognition is that the first difficulty that we face is that we are unable to say what we want to measure. From an etymological point of view, it's really difficult to define the traits that we want to measure. Here, we have the scales that we use to describe the behavior that we had, and we used like a perspective. We used the reaction that they had towards the novel stimuli that was going to be presented. Furthermore, we have the traits and how did we scale. To build these scales, what we did is to contact owners. It's really important to keep a connection to owners because these are the people who are directly working with donkeys. And we contacted them and we described what we wanted to measure, and they said, okay, I call that this way. So we get to apply like a real cognitive perspective of the process that we were going to measure. How did we avoid subjectivity? Because, I mean, what happens with behavioral genetics is that what seems to be well behaved for me is not well behaved for others. What we did is we carried out the same test, but we used 3 appraisers over a smaller sample. We trained them, and what we find out is that the first thing that we did is to check whether the appraisers were able to score those animals in the same way when they reviewed videotapes that had been taken during the operant tests. Then, through the observations of 3 appraisers, what we got is we statistically measure whether it was possible to say that these scores were being reliable. For your information, the scores that we have were all in this range. I mean, it was like 0.60, 60, 70, which declared that the scales that were being used as they relied in actually like the etymological basis was really fixed, and it was fixed among the owners. It helped us to train the appraisers to think like the owner used to think. So that's the reason why we received that great results. Then this is the operant conditioning test that we carried out. I don't know if it's moving. I think it is. No, wait. Well, what we did is to try to make the donkey to cross over an old cloth using different reinforcement methods. Okay, the first one was a soft voice. This was regarded as neutral reinforcement. See, we did anything with the donkey. We presented the novel stimulus and we see what the donkey wanted to do. Second treatment, it was a negative reinforcement, as the owner was likely to, the handler pushed from the rope, and it stopped the pressure when the donkey agreed to move. Okay, so it's possible. All the experiences were recorded by handler B, for example. Okay, third one was the donkey was offered a treat, and it depended from one owner to another. When we try to describe this research and we try to publish it in journals, what we have is that if you use different treats, you may have variation. But the truth is that when you try to give a treat that is unknown to a donkey, it's not likely to make any response. And the truth is that owners doesn't have like different kinds of trees in their farms. They only have one. I mean, if bread works, they use bread. If carrots work, they use carrots. So that's the reason why we use this. Third tree. This fourth treatment consisted of the motivator, which was proposed by the research by Amy McLean, which is a plastic bag attached to a stick, and believe me, it really works. It really works. So, I mean, in fact, the response that we have was more control, because some of the owners were telling us to fill a bottle of plastic and fill it with like pebbles and to move it, but that gives like uncontrolled response. Believe me, I have tried. Sorry. Okay, now, the fifth treatment consisted on 2 people leading the donkeys. So And sixth treatment consisted of someone clapping a donkey's back from the rear. Sometimes it was effective, sometimes the donkey didn't pay attention, sometimes it depended. The good thing is that we were likely to find a lot of variation between animals. We were able to find that for the genetic structure. Okay, then this was the first phase of the test. The second phase of the test consisted of presenting different stimuli to the animals. Some stimuli, we assessed the response to the veterinarian. I presented this paper to a journal and I received the question, how does a donkey know that the veterinarian is actually a veterinarian? So, it was challenging, but I mean, donkeys know. I don't know how, but they know that's a veterinarian. We blare a horn once, 3 times. We play a car engine, which is normally a sound that they are familiar to, from a different gadget. We saw the relationship with other animals in the farms from different species, and we also see how they relate with animals from the same species and from the same herd. And these were the scales that we finally, after this research, we got. We got the first scale, which classified the animals in hyperreactive, neutral, or hyperreactive, 12 categories regarding the mood or the emotions that the animals were likely to display, and a scale which ranged from 1 to 5, describing the intensity of the response. When we process this data statistically, what we found out is that the cognitive processes that were related to intelligence that we are likely to find in human approaches were likely to gather at the same distance. All this: curiosity, docility, memory, stubbornness, concentration, alertness, cooperation. And we have 2 characters, which are trainability and ease of handling, which were kind of in the middle. So it may be because of the training approach that we get with donkeys. We also know that coping style cluster, those traits related to the reactivity of the animals were split from the very beginning. And we have a more general cluster, which is quite a little bit disorganized and unorganized, because we can find out that there's slight difference concerning the distribution of the data. How do we knew that we need to keep ease of handling and trainability? We see at this curve. You see when the line falls, so it tells us that it could be gathered under the intelligence cluster. It should be considered in a general cognition because it's quite little apart from it. So, to depict this in a better way, we find out that coping style was separated like earlier, then we have general cognition, and then we have intelligence trait, which were able to be separated from the rest of traits. And just only by analyzing the data that we have come from the field. It's true that we knew what we were going to have because if you have a look to literature and to bibliography, and you do things like considering opinions of owners and getting all, you barely get surprised at what you find. Okay, so this is a huge table concerning the effects that we control. This is the effects that we control for all the 4 traits that we measure. Just to bring your attention, I would like you to know that reinforcement type was the most important for all the traits. The way that we train our animals, it's really representative of the behavior that they express and even of the learning processes that they have. For you to know, it's like moon phase at the time of birth has almost the same value of other factors that we thought that would be more relevant. For example, look at them and look what's the value for the moon phase at the time of the evaluation. Right? Cold. We got one curious thing that we find out is that we had 5 genes. We were showing depressive signs. And we thought it was just because they were not in the mood to collaborate. But when we traced those genes back, we found out that the late third of their gestation happened during a cold wave, the hardest cold wave that we remember. If you go back to literature, you may find that when there's cold waves during gestation, these are likely to move forward faster, so that these animals are born with problems with cognitive problems. So it was true that the only animals that were showing these kind of signs all belong from the same year and from the same season. So we could trace back what had happened in their history. I encourage you to have a look and to make questions, because if we discuss all the factors involved, we could be here for ages. But if you have any particular intention to discuss any factor, we can speak about it personally. This is what we can account from our model. The first table, the green one, pay attention to R squared. It says that meteorological factors are able to explain from a 28% of the variability in behavior to a 37.5% for learning. If we turn to this model gathers, for example, all factors related to mother, father, season of evaluation, owner, reinforcement techniques, and we were able to explain from a 61% to a 70%. So meteorological factors do play a role, they are important, but most of the factors regard the husbandry system and the farm and all other factors. Then, we were able to measure the variability, but we need an extrapolation measure. So we decided to apply the common constituent for humans, which is IQ. What's IQ? IQ is the relationship between the mental age of an animal and the chronological age of an animal multiplied by 100. So, what we do is we measure in a population of donkeys, we see which is the main score of those donkeys obtained for a certain cognitive process. And then we establish this at the 100 IQ position. Then from that point is equal to the age in which the animal is able to reach the score that it would be expected for him to expect or for her to expect, given his chronological age. Then we move forward or backwards in intervals of 15 points, each one standard deviation increase or decrease. See here. This is the work that we have done. In the first picture is one of the experiences that we have carried with hunting dogs. And this is one of the experiences that we carried out with fallow deer. And this is the one that we actually carried with donkeys. And what I want to say is that we can use many different traits. I mean, we can measure scores for the animals for certain cognitive traits, or we can score how much does it take for the animal to accomplish a certain task, and we can use everything. The only thing that we may have is that the tables that we obtain to short may be placed on one way or another. For example, what we did in donkeys is we set these scores so that we could decide which animals were over the average and under the average. And what gets us to compare is that this way, as you are working with a population, you're able to say which animals are in the median and the average population. I mean, they receive the average score for the population, which are under and which are over the median. So we can compare different animals and different species independently of the test used, because we are always, it doesn't matter if we test a memory in birds or if we test memory in dogs. We are saying that these animals or this certain animal is in the average or not. So comparing donkeys to humans, what we found out is that this is the human IQ distribution that we found. And in a donkey, in our donkey population, what we found out is that IQ was slightly displaced to the left. This doesn't mean that donkeys are less intelligent or more intelligent than humans, but it says they follow the same distribution. When we see this, for example, in the case of humans, we have the 68% of the population ranges from 85 to 150, and 77 of the sample in donkeys range from 30 and 95. 95 of the population falls within the range in 70 and 30 and 130, and 97 of the population is about 15 and 125. And it happens with the 2% of the population, which was or below 70 or over 130. And in donkeys, we have that less than a 3%, where the sample is about 130. Why did we receive this high value? It's because some of the cognitive processes that we tested, which, for example, were ease at handling or the way that they enter their stables or not, is easily accomplishable by all donkeys independently from the age. I mean, you get likely foals that are likely to be easy to get into the stables. So what we find out from here is that there may be some cognitive structure underlying cognition, and the same distribution attempts for that. Then, out of the cognitive processes that we found, if you pay attention to these three colors, what they say is that there are actually some variations, so we can select for cognition. When I've been presenting this in different places, they ask me, why do you want to select a donkey for cognition? If you have a donkey who is able to interact better with the environment, he may be more successful, and he may make the most of what is in the environment of the donkey. Furthermore, if you have a donkey which is easier to train, you may it may be more profitable regarding time or money. And the values for heritability, which surprisingly range from 0.8% and 40%, tells us that indirectly owners may likely have selected their animals for a better behavior, and to get the animals that were likely to be trained in a lower time at a lower price. And that's my last slide, in which I'm going to speak about the correlations that we found between the characters. Okay, for the coping style cluster, what we find out is that the animal, the further the animal displayed a certain extreme mood, for example, extremely calm or extremely in discomfort, it doesn't mean that the animals were likely to show a high intensity response, which is quite particular from donkeys. They could be in really great stress, but they are not likely to display signs of suffering from that stress. It can be noticed from the genetic correlation, which is really considerable. It's like 0.43, 53. Then this is a great trouble, and I want you to pay attention just to two things. I invite you to have a look on your own and see that when you have a positive, we have the diagonal, it's the heritability. It is the percentage of these cognitive processes that it's inherited from one generation to another. It ranges in donkeys from 8% to 38%, what we have found from our study. And when you have a positive genetic correlation, it means that if we select for a certain trait, we may indirectly select for another one. If we have a negative correlation, it says that if you select for some trait, you may be being a drawback for the other trait. So that one of the things that I feel it's more important, if you have an attention to alertness, it shares a low correlation with all the rest of traits. So it means that when you have a donkey that is pretty aware of what is around, he may forget about displaying intelligence reactions. But actually, I think being that aware can be quite a natural part of our donkeys. I mean, they prefer to be aware of what's happening around. They measure everything around, and then they react. For that reason, one of the things that I find more interesting is that when we consider getting in and out of stables, and we compare it to docility, we see that there's a negative correlation, which at first can seem to be curious. But what we know is that docility for us is when an animal is easily convincible. I mean, you can trick them to do what you want them to do. And I say trick them because with donkeys it's mostly trick them. What happens is that animals are likely to go to the place where they feel safer. So if you want to select for a docile animal, you may not pay attention to the way it enters to the stables. This is not a relevant measure because if you select, I mean, you have a donkey which easily gets into the stables, this may be detrimental for the docility of the animals because it is not going to his house when you're telling him to go. So just have a look through all the processes, and if you have some question, I mean, I know this is like some kind of messy and sometimes it'd be hard to follow, but I hope you enjoy it, and I really enjoy it much. Okay, thank you.